if biochar can really do that, it might actually mean that climate value alone would fund char. Certainly not yet. I know there are a couple other people that wanted to talk about it.
Well, it's interesting in Dominic's paper, the total amount of sequestration that you can get over 100 years at the maximum sustainable potential is 67 gigatons.
Well, he shows the ramp up.
That's right.
And I had his graphs in here, and those are the slides I really wanted.
67 gigatons when you take into account the lost sequestration due to taking the biochar away from taking the biomass away from the soil. The net sequestration is 67 gigatons over 100 years, and already at 50 years you've reached the level that you can incorporate into the soil economically beneficially. So the rest you have to do some of that. So we're comparing that 67 gigatons with what you point out, which is several hundred gigatons. So biochar is kind of, and that's maximum sustainable potential over 100 years.
Well, but
the biochar is like 10% of the solution.
The other thing about the maximum sustainable potential was purposely a very conservative number. It didn't include forestry. It purposely didn't include any kind of plantation. It's possible that if we could bootstrap our way into using marginal land, then you get into things like competition for water, which is why Aminette and I have been talking about could you do coastal deserts. But you're right. It's.
I mean, there may be a factor of 2 in there, but that makes it 20% of the solution.
I think, though, they did take into account competition for biomass pretty thoroughly. They were picking such a low level of intervention that they were trying to make very sure they weren't in any competition for ongoing carbon needs in the soil. They purposely picked very conservative numbers. But still, it doesn't add up. We better pray that CCS does work, that absolutely everything does work, and we're going to need all of it.
Well, I totally applaud your presentation because it's very much aligned with the conclusions I've come to. I want to support this notion that the sustainable concentration in the atmosphere is probably under 300. Because when you think about it, the climate change we're getting now is due to what force we had in the 80s. In the 80s, in 1988, we were 350 parts per million. But the pole caps were already melting. The glaciers were already melting. So the glaciers were melting due to the forces that existed in the 50s, which is probably around 320 parts per million. But just think about it. Once you start melting glaciers and melting pole caps, you've got a positive feedback because the albedo.
Well, particularly
you definitely put yourself into a positive feedback place.
And then we start liberating methane when we let this go too.
There's a huge spike in methane concentrations.
And methane is relatively short-lived, but it's a very strong forcer. So I really think that we have 3 different time scales of climate problem, and most people are aware of the middle one. So the middle time scale is trying to stop emitting CO2 because it's going to have an impact over a long time. And so that's where all the political fight is. The other 2 time scales that we tend not to be aware of are the long-term corrective time scale, which I've been addressing here. What's the intergenerational problem we've set in motion, and how, theoretically, how could we possibly fix that? The other time scale that almost nobody's aware of is the very short-term emergency out of control time frame, because we're starting to set off feedback loops that are way beyond what we're doing with methane. And I actually think that we will need cloud brightening. It's the only thing we've got, or that or sulfur, to arrest those before they take off out of control. The trouble is if we don't have things to remove the CO2, we will be locked into that kind of engineering forever. And we're essentially locked into it for probably several hundred years already.
There's another technology that I've heard of, where it looks to me, after thinking about it for more than a year, to be as good as a potential partial solution as biochar. And that is wave-powered ocean pumps that bring cold, nutrient-rich water from depths of like 1,000 feet to the surface. And there's also plankton, actually recurring plankton, that is in cold water. And all you have to do is get that nutrient-rich seawater to the surface, the photosynthesis can happen, and you get algal blooms. And the machine technology, for my passion, is really simple. It's simply a buoy that goes up and down with the waves, and a one-way valve at the bottom of a 1 meter diameter drinking straw. Drinking straws, polyethylene plastic sheet tube. So I just wanted to mention that, ask you if you've heard of it, because you're aware of it.
I have heard of it. What we're going to be up against in all of these things is trying to evaluate the ecosystem risk of doing something. In some cases, I think, versus the ecosystem risk of not doing something, because if things just take off, we're going to cause extinction of much of the life on the planet. We are probably going to need all of these things, and there are communities of marine biologists looking at this stuff. The conventional algae bloom idea is you put iron filings in the deep southern oceans where there's sort of one seasonal bloom usually, and because iron is in short supply in the very deep southern ocean, instead of there being two blooms there's one, and so the idea is that we would basically be doing what happens in most of the rest of the ocean by seeding that area of the ocean. Of the ideas, that one seems fairly safe. All of these things become scary, and looking at the numbers, I would predict we will end up experimenting with all of them. Of all of them, I think biochar is by far the safest and has multiple benefit streams, including trying to bootstrap agriculture into areas where the land is now degraded, so we could actually pull pressure off of intact ecosystems rather than destroying what remains of forest land, because we're trying to do afforestation at the same, for increased sequestration. You get a lot of carbon removal there, even if it's capped. But yeah, I think there's only so many things to do, and they all rest on photosynthesis, either on the land or in the ocean. And photosynthesis is ultimately the driver that takes carbon out of the atmosphere. And there's more ocean surface than land.
Just a point that isn't often appreciated. Policymakers are looking for a 60% reduction in total emissions on a global scale. The only stable place is zero emissions. If we make a 60% reduction in emissions, we will stabilize the concentration for a few years, but because of what Jim said, the carbon dioxide coming back out of the oceans and our continued emissions at 40% of the level, it'll start to climb again. The only actual stable place is to cut our emissions to zero. And if we do that, then the concentration in the atmosphere will start decaying at the rate of 40 parts per million in 100 years, or about 100 billion tons a year will come out. That's in our favor, but the only way we can get there is to cut our emissions to zero. Now, we're never going to cut our emissions to zero because there's always going to be rogue emissions. You can't get the whole world and every process and all the fires and things to suddenly stop.
I think there's actually two different fallout mechanisms. And so there's a comparatively rapid fallout mechanism that's sort of short-term carbon cycle, biological. And then the long-term fallout cycle is the geologic carbon cycle.
300,000 years.
Yeah, and it's a very, very long cycle. And if your ocean acidity level is up too high to form carbon-based life shells, what happens to that cycle? It's all programs. We are in dicey territory. I remain optimistic, and I'll point to two reasons why I'm optimistic. This is at least the second climate crisis and at least the second, if not third, energy crisis in the history of life on this planet. So we, our ancestors, have a very good track record of responding to crises where we screw up the planet and then have to fix it. The first energy crisis was when we assembled life out of the primordial soup and ate the soup. And we ate the soup until it was pretty much gone, at which point we had a real energy crisis. No more soup left. And we had to invent photosynthesis.
And that only took like 500 million years?
Well, time frames are different now. And so we invented photosynthesis and went merrily along capturing sunlight and eating it and using photosynthesis and chucking all this excess oxygen in the atmosphere, which had to rust all of the iron in the lithosphere, which had to be cycled underground over a very long period of time. So it was buffered by the geologic cycle until all of the iron rock had been rusted. And the oxygen level spiked. We had our first atmospheric crisis, the oxygen crisis. And we got to the point where we were spontaneously combusting. Carbon-based life forms would just catch fire because there was so much oxygen in the atmosphere. And so we had to hustle around and invent respiration. And we invented respiration, and we went merrily along breathing this oxygen and making complex animal forms. And so those forms have gotten clever enough now that we're liberating all kinds of other energy reserves, and we've made a little bit of a mess. I remain optimistic that life is clever enough that we now will do this in a short period of time because we don't have billions of years anymore. We have to do it in the time around. And we'll do things by building ocean pumps and biochar and all this stuff. And my hope is that we keep as much of existing biodiversity around as we do this, because that's the thing we can't really put back together as far as we know. But it's going to be a very interesting world, and I would predict that as these crises begin to really hit, we reorganize society in response to real problems. And we're still in this funny little dance where we have to play this economic game trying to work on the real problems. I'm somebody doing that, running a little for-profit company trying to build equipment to get this started. Anybody else wants to?
Well, I mean, it's optimistic to go this way, but we're still, as the easy oil runs out, in India and China, we're seeing more coal use. So are we seeing, are there any significant improvements in clean coal?
Well, I'll say one other thing that's probably controversial in our networks. Well, first, no. Clean coal is like military intelligence.
Like what?
Military intelligence. Clean coal is a marketing campaign.
Right.
The one thing that I've become very curious about in the last couple of months is some fast breeder nuclear technology. And the reason I'm curious about it is because I've been profoundly anti-nuclear my whole life. And there were about 5 reasons why I was. Well, the nuclear technology made a mess that would last for millions of years. The technology produced, it was easy to make materials that could be reused for weapons. The technology itself was so badly designed that it could take off and explode and make a big mess. And it was very expensive. And if what I've heard about this fast breeder technology is true, it actually takes material that is now waste and mixes it with weapons grade material and makes a mix that's very hard to